All right, so let's go to the next part. This question was designed to test your facility with 2x2 matrices. Right, now about this matrix here, remember the formula for 2x2 inverse matrices. So I'm going to get A inverse is equal to, I'll leave some space for the determinant, switch the diagonal elements, minus 5 to, and then negate the off diagonal elements, like that. And the determinant is going to be minus 10 minus 0. So that's 1 over minus 10. So that gives me 1/2 x over 10, 0, and minus 1 over 5. Okay. Now, to find a to the fourth, the best way to do that is first find a squared, which is 2x0 5, 0 minus 5, times 2x0 minus 5. Okay. And that's going to give me, let's see, if I do row and column, I'm going to get 4, and then here's going to be 2x minus 5x gives me minus 3x, and then I'm going to get a 0 here, and then I'm going to get a 25. Okay. Now that's a squared. If I want a to the fourth, I can take a squared times a squared. Okay. And do that, and I don't remember exactly what the answer is, but that's how you do it. You can check that out for yourself. If you have trouble doing it by hand, you can do it using Wolfram Alpha. Right, now about A transpose minus A transpose A, it's the same way. Remember that A transpose is equal to 2x0 minus 5 times, transpose takes the upper triangle and turns it down to the lower triangle, 2x minus 5, 0. Okay, and you get your result there. Then you take A transpose A and you subtract it. Again, if you have trouble with that, you can use Wolfram Alpha to get your answer there. All right, so let me just go on to question 7 quickly and finish this off. All right, so here again, it's a question of matrix multiplication. We have 5 minus 2y times 0 minus 3, 1 times B transpose. B transpose is this way. X1, 4 times 2, 1, 0. And that's going to give you C transpose. C transpose is going to be 7. The diagonal stays the same, and the off diagonal switch. So I have minus 8 and 1. All right, so if I do this matrix multiplication on the left, I'm going to get, and if you don't have this by now, you better practice. Just make up matrices and practice and check your work with Wolfram Alpha. Right? So here we've got 5x. I'll do out the steps is 5x, and then this is going to be minus 2 plus 4y here. All right, and then the second one is going to be 10 minus 2 gives me, I think yes, I made a mistake in the test. This was a plus 8, so this turns out to be 8 here. So that does work out right. And then here I have 0 minus 3, 1, which gives me a 1 here. And then here I got, let's see, I think it was minus 3. Okay. And you have that equal to 7, 8, 1, z. Okay. So notice that the 8 works out, the 1 works out. This entry here is equal to 7. This entry here is equal to z. So what are the set? So I asked for all solutions. What are all solutions? You have 5x minus 2 plus 4y equals 7 is one equation. I don't need to write down 8 equals 8 and 1 equals 1, and then you have z equals minus 3. All right, now this is a system of linear equations. You should write this in the same way that you've written other systems of linear equations. Of course, I can bring the minus 2 over to the other side, so I get 5x plus 4y is equal to 9. And z equal to minus 3. Okay. So the question, which are the dependent variables, which are the independent variables? Y is an independent variable. Y is a free variable. Okay. So you can get your answer in terms of y. So you can write your answer like this. X, y, z equals, now I know that z is equal to minus 3, so that's set. Y is equal to what? Well, y is a free variable, so I'll set that as y. And then x, what's x equal to? Well, I need to solve this equation for x. If you solve that equation for x, you're going to get 9 minus 4y divided by 5. Now you could also write this as a constant vector plus a multiple of y. The constant vector would be, from here I get 9/5, 0 minus 3. And then here I have plus y times, well, this is going to be minus 4/5, 1, 0. So that's the set of all solutions to this equation. And that's it.